Today we're looking at science. Now, I would like to find out from you, what have you been doing to prepare for your science examination? I hope you have been studying and I hope you have been practicing. We'll start this session with a brain teaser. So, this is our scenario. A boulder, a cobble, and a pebble are in a gorge, a lake, and a valley. Now listen carefully. The rock in the valley is larger than the cobble. The cobble is not in the lake. Question: where is each rock? So we're going to try to see if we can work out where do we find each rock. So we have prepared a little table for you to help you to place the rock. All right, what would you start with? Okay, so we know that we have all these three types of rocks and they're in a gorge, a lake, and a valley. We are told that the rock in the valley is larger than the cobble. So obviously the cobble is not in the valley. Yes? And we know that the cobble is not in the lake. Good? All right, so let's see if we can find out where do we place each of these rocks. Have you worked it out yet? All right, so the boulder is in the valley. The cobble is not in the lake, so the cobble must be in the gorge. So what do we find in the lake? The pebble. All right, so that is our brain teaser for today. We're looking today at some assessment tasks for grade 6 science. But just to remind you that when you're looking at these tasks, we want you to be using your reasoning skills. For each question, there's some information that is given, and so you must always seek to correctly interpret the question, right? For science curriculum-based tests, you will be given questions that have different options, and so you must examine the options to determine the most suitable answer. And of course, you're going to choose that answer based on the evidence presented in the question. And as always, please remember to analyze and interpret any information given. So let's get to it and let us see if we can try our first question. Which of the following activities represents a reversible change? All right, so our first task is for us to remember what a reversible change is, right? You may remember that if something can be reversible, it means that we can go back to our original starting material, all right? So let's think about it. If I bake a cake, can I go back to what I started, the materials I started with? Heating a piece of wax. If I heat the wax, can it go back to the original solid wax? Toasting bread and burning a piece of wood. So of those four options, which would represent a reversible change? Okay, let's check out the answer. I hope you have tried the question. Let us see what the correct answer is. Well, if you got heating a piece of wax, then you are correct. Because if you heat wax, as soon as it cools, it will go back to the solid form. All right, let's try another question. Now, this question relates to the unit, the environment. Read this question. So there's a diagram that shows an area of land that a farmer wants to use to plant his crops. And you're asked to choose two methods. So let's look and make sure that we're clear where we are to choose two methods. And it's the two best methods that the farmer could use to protect the soil and his crops. All right, so it means that you would need to remember how we protect the soil, what sort of farming practices that we should use, all right, to prevent things like erosion and soil degradation, all right? So let's look at our options. We have contour farming, crop rotation, mulching, and terracing. Again, try to look at all the information given. It is a farming on the hillside, so that's very important. Because it's on the hillside, then the methods we choose would have to apply to that type of farming. So which two methods would you choose? Write them down and let us check our answers to see if we have the correct answer. So because it's on the hillside, we should be considering contour farming and terracing. Why those two options? Right, because those two options prevent the washing away of the soil. Okay, next question. Now here's a question that has to do with soils. So you would have looked at soils in grade 6. You would have looked at the fact that these soil particles may be different in terms of the size of the particles and how quickly they allow substances like water to pass through. So here's the question. Equal amounts of water was poured into 3 funnels containing the same volume of stones, sand, and clay. Why did we specify that it's the same volume? Because we're trying to make the test fair, all right? And we're using the same amount of water. So the question is, looking at the diagram, which represents the correct order in which water would pass through each funnel? And note, you're ordering them from the slowest to the fastest. So what sort of information would you need to remember to be able to answer this question? You need to remember, for instance, that comparing sand and clay, for instance, right, and stones, which of these would have the larger particles? And hence, which of these would the water pass through the fastest? And then, of course, we can compare to see which one would be the slowest. All right, so look at the options given and let us know which one do you think would be the correct order from the slowest, to the fastest. Have you tried it yet? All right, let's check our answers. So this is the answer we're looking for. Clay would be the slowest because the particles in the clay soil, they are finer than those in sand. And of course, if you have stones, if you ever put some stones together, you'll see that you have a lot of space between the stones, and so the water would flow out faster through the stones. So the correct order is clay, sand, stones. Very good. So we have now some questions on sound. I hope you have reviewed sound already, all right, as we prepare for examinations. So we're given some statements about sound, and we're going to indicate using a tick which is correct or which is incorrect. So here's our first statement. Sound only travels through air. Do you think that's correct? All right. The loudness and the pitch of a sound is the same. Now that means that you have to be clear as to what is the pitch, right? And how that is affected by can you have a loud sound that has a high pitch and a loud sound that has a low pitch? Can you? All right. So if that's the case, then it's probably that the loudness and the pitch is not the same. All right. Sound travels in all directions. Is that true? Here's another statement. Hitting an object harder changes the pitch. Do you think that's correct? All right, well, choose your answers carefully. Look at the statements again. Remember what you know about sound, and let us check our answers. All right, so we know that sound can travel through solids, liquids, and gases, right? So obviously, sound will not only travel through air, so that statement is incorrect. All right, let's try again. The loudness and pitch of a sound is the same. No, that is not correct, because we were just discussing earlier that you can have a loud sound of a high pitch and a loud sound of a low pitch. So they are not the same. Here's another one. Sound travels in all directions. Yes, from the source, the sound will travel in all directions. All right? So that is correct. And our last statement, hitting an object harder changes the pitch. Again, if something is at a low pitch, hitting it harder will only make it loud. It will not change the pitch. So that is how we would answer that question. All right, let's try another one on sound. All right, here's the question. Mark wants to block out the noise of the drum from his brother's room. He places an alarm clock in a box lined with different soundproofing materials and measures the loudness of the sound produced. So he probably has some way to determine how loud the sound is, all right? And so he uses 3 different situations. He uses a closed box lined with cotton, closed box lined with foam, and a closed box lined with wool. So remember, he's trying to find out which material, right, is best at reducing the sound level, all right? So which 2 things, again, we're asking for 2 things must Mark do to make his investigation a fair test? Look at the options given. Should he measure the sound level from the boxes at the same time? From 4 different boxes? Using the same box? Using the same alarm clock? Take a minute and try this question. What 2 things should he do to keep his investigation fair, to make it a fair test? So you may remember that in a fair test, what must we always try to do? In a fair test, you're only supposed to change 1 thing at a time, and you keep everything else the same. So if he's trying to see which material is best, all that should be changing is just the different materials, right? But he should use the same alarm clock, shouldn't he? Of course. Because if you use the phone in one and the alarm clock in the other, then that is not a fair test. What else should he keep the same? All right, let's see. Let's see our answers. So, yes, he should use the same box. Because notice if he changed the box, it's probably that it will change the sound level. Right, good. So we want the same box and we want the same alarm clock. And so I hope you see that this question, we have to have knowledge of designing fair tests. Very good. Let's check the other question. So this question is on light. So you should be studying, reviewing the unit on light. A student is investigating the formation of shadows using the apparatus. So let us look closely at the apparatus that is given in the diagram. All right, we have a light source, metal ball, so we're shining our light on that object, which is a metal ball. We have a screen, yes, and it forms a shadow. Very good. All right, so the question is, the student makes the following statement. If I move the metal ball closer to the flashlight, the shadow will get bigger. Look at it. If I move the metal ball closer to the flashlight, the shadow will get bigger. So we're going to look at that statement and determine what type of statement is that based on the options that we have. Is that a conclusion? Is that statement a method? Is it an observation? Or is it a prediction? So obviously you would need to remember the steps in the scientific method. Okay, so let's see your answer for this question. Did you choose prediction? Yes, it is a prediction because notice it's not as if he has carried it out yet. He's saying, if I do this, then the shadow will get big. A matter of fact, if he had worded it in such a way to say, if this happens, then that will happen, right? It would actually be forming a hypothesis. All right, so please review those steps in setting up your scientific investigation. All right, we're still in light, in the unit on light, and here is our question. Bicycles and trucks are often fitted with reflectors. You normally see these reflectors on the back of bicycles and on trucks, right? So we have these reflectors on the back of trucks and bicycles to help drivers to see. So the question is, which statement best explains how the reflectors work? So the reflectors, do they bounce light from other sources? Do they contain special materials that produce light? Is that what's happening there? Do they have a special paint that glows? Do they produce their own light? How do they work, really? Okay, look at our options and choose the best one, the statement that best explains how they work. All right, let's see if you got the answer that I have. Yes, that's what happens. As the name suggests, the reflectors are bouncing the light or reflecting the light. So the light from the car, the headlight or some other light on the car, when it touches the reflectors will bounce that light, and so you're able to see that bicycle or truck. All right, let's see another question. We're still in the unit light. Winston has 3 identical squares made of different materials, and he's going to use a flashlight to shine onto each square and to measure the amount of light that passed through. And we're given some results. So look at that table with the results. And you can see that based on the different squares, we have different amounts of light passing through. So look carefully at the results in the table. Now you are asked to use a tick to indicate, based on those results, which material do you think is translucent, which is transparent, and which is opaque. So, what do you need to remember in order to answer that question? What do you need to know about translucent, transparent, or opaque objects? Yes, opaque objects, does not allow any light to pass through. Good. Transparent objects will allow all the light to pass through. And translucent objects will allow some light to pass through. So, using that information that you know, right? Let's see if we can interpret the data that we're given and to determine which is translucent, which is transparent, and which is opaque. Look at the table again. What did you choose? All right, let's see. So, opaque, let's start with the opaque object. The one that had no light passing through, 0 from the table, would be opaque. Translucent allows some light. So the next value, 600 units, would represent that object which is translucent because it allows some light. And for the transparent object, we would have allowed most of the light to pass through, so that value would be the largest. Okay, so obviously here we are required to analyze and interpret the information that we were given. If you got all answers right, very good. You're on your way. All right, here is another question on light, and this one is trying to see how what we remember about reflection of light. So you're given some information. Light reflects off shiny surfaces. We know that. Very good. And we're given some diagrams, and we're to look at the diagrams to see which diagram shows the direction light travels when we see an object in a mirror. Okay, so let's look carefully at the diagram. So in A, and when we're talking about the path that light travels, we generally represent it with that line with an arrow, all right? We call it a light ray. Okay, so let's look and see where the light ray is going. So in A, the light ray is moving from the object, hitting the mirror, and in A though, when it hits the mirror, for some reason we have our eye, or the eye in that diagram, also sending off a light ray. Is that what happens when we see objects? Do you think that is the correct diagram? Let's look at B. B has the light ray coming from the object, yes? And then when it hits the mirror, it basically reflects and go in the opposite direction. And our eye picks it up, right? Does that sound like the correct diagram? C. C has our eye, yes, the light ray coming from our eye, bouncing on the mirror, and then going on to the object. Is that the correct order? And the last one, D. D has the light rays coming from the mirror to the object and from the mirror to our eyes. Is that the correct way in which we see an object? Remember, very important, that we are able to see objects how? We see objects because the light, yes, the objects reflect light that is around them, and that reflection, that light is seen or is interpreted by our brain, of course, and seen by the eye. So it works in that way. All right, so what did you choose as your correct answer? You should have chosen B, because the light is traveling. We're seeing the light reflected from the object first. That hits the mirror, and then, of course, we see that using our eyes. All right, so that is the correct path that it should take. All right, we're now looking at a few questions that has to do with properties of materials. Mr. Smith wants to determine the best brand of paper towels that he should use to soak up water in his kitchen. Yes? So we're given some information about the different brands that he has and how much water was used. He uses pieces of paper towels of the same size from 3 different brands, and we're calling them A, B, and C. So brand A, brand B, and brand C. And he's using 150 mils of water each time. So what comes to mind when you think of that scenario? Fair test. Very well. All right. So they're using the same amount of water, 150 mils, yes? But they're only changing the brands of paper towels. So we're using 3 different brands. And so we're told that the number of pieces of paper towel used to soak up the water, that is given in the table. So look closely at the table. I'm going to give you a minute to look at the table and to see how many pieces were used for each brand. Okay? Good. Now, think about when you have something spilled at home. Your paper towel should be able to clean it up completely, yes? And you don't want to use too many pieces, right? So if you have to use too many pieces, it's probably not very good, yes? You want to use the least amount to soak up the most water. All right, so look at that table with information again and try to see which is the best. And here we're looking at the property of absorbency. Yes, that is the word. That's a property. How quickly or how completely it absorbs the liquid. We're to order them, yes, from the most absorbent to the least absorbent. All right? The most absorbent would be the one that required the least number of pieces, yes? And the least absorbent would be the one that required the most pieces of paper towels. All right, so let's see our answers. So our options should have been B is the most absorbent because it only required 4 pieces. C would be next. And A, of course, would be the least absorbent. Okay? Yes, I hope you have gotten that answer. All right, here's another question again on the unit properties of materials. So a student wanted to determine which material could keep her soup warm for the longest time. What property does that suggest? We're looking at heat conductivity. Yes, which one will keep it warm for the longest time? Okay, so we're given some steps that the student used. She carried out the steps below. She placed the same amount of soup in cups, but they're made of different materials. Yes, A, B, C, and D. That's what we're calling them. And she measured the temperature of the soup in each cup at the beginning and at the end of 10 minutes. So they're using the same time period, 10 minutes, and you're measuring the temperature. Yes, so we are given a table again with some results. So as you can see from these questions, you have to be able to use the information given, analyze and interpret the data that you're given. So let's look closely at the results. So look closely. So they all start at 70, but the end temperature changes based on the different materials. Remember, you wanted a material that would keep it warm for the longest time. So what would that suggest? At the end of that 10-minute period, the temperature should be the highest. So the end temperature should be the highest, because that would mean that it has kept it warm. So look closely at that table. Which one would keep it warm for the longest? And so it should not be able to release that heat too quickly. All right? So the correct term really is insulator, best insulator to the worst insulator. So obviously, material D would have kept it warm the longest because the temperature was the highest for the end temperature, right? So that is the best insulator. And going down the line, we would have material C, material A, and then material B. So here we're looking at the property of conductivity, and here, because we want it to be kept warm, we want the material that is the best insulator. Okay? All right, so that's where we'll stop for today. I hope you have been getting the questions. If not, you have an opportunity to go back to your books and review the materials. Yes. So good luck on your exams, and remember to practice, practice, practice. Because if you fail to prepare, then you prepare to fail. See you next time.